Hey everyone, welcome back to the workshop. Today I am getting caught up on a video that I promised long ago, and I've just been busy or other things have come up, but we're going to talk a little bit about LED lights. And this came up because a couple years ago I got my original X-Tool D1, needed an enclosure for it, and built this one, offered the video up and some plans on it. One of the features that I've included in it though is, as you see, it's all lit up in here, but when I open the lid, these top LED lights here turn off, and that's because I've wired in a switch here, and you'll see they get on and off as that switch is hit. So I've had a number of questions on that, working with LED lights in general, so figured I'd put a quick video together on how I did this, but also working with LED strips just in general, because you can work with them in a variety of projects. So if this is something that sounds interesting to you, want to learn more about it, stay tuned. We're going to jump right into it. All right, so the first thing we need to talk about is the types of LED lights you're going to be using. Now, there are a number of kinds out there, and so that depending on your complexity of your project, you might want to take advantage of them. We are using the most basic LED lights. They just have your power connections, so they're basically on when you apply power or they're off when you remove power. There are also RGB lights, so they'll have a third connector point on there, and that will allow you to send a signal to tell the lights be a different tone, because they will the LEDs are set up that way. They can change color and usually brightness. And then there's some with a fourth that it can actually have sections do different things. So that's where you would get like the rainbow effects of different lights or different LEDs on the strip lighting up different colors. Sometimes you can add motion and such, but again, we're just dealing with the two pin style here. The other thing to consider is the voltage. There are a variety of different voltages for LED lights in these strip style that we're looking at. They tend to be either 12 volt or 5 volt, and that allows you to use either a 12 volt power supply, such as a 12 volt battery or 12 volt power adapter, or 5 volt tends to be for your USB power devices and such. So depending on what you have for a power source for your project, you're going to want to make sure you get the right voltage, and you don't want to mix and match them, because you'll either underpower them, they won't light up, or you're going to overload them and they'll burn out. So the ones we're looking at, they come on these rolls, and they come in a variety of colors. And then also in the white range, you'll get different color temperatures. And that's going to, again, be personal preference on the project you're working on. Obviously, for lighting up an enclosure, we're going to be looking at white, but you may want to use a warmer white or a brighter white. It's up to you. I've played around with the different ones, and in here, I tend to have a brighter, like a 5000K, but in projects, I might want a warmer light, so I'll drop down to about the 3000K. Again, that's personal preference or what's available for you. So to work on this project, we are going to need a variety of supplies and tools. You're obviously going to need your spool of LED lights. These are available online, many different retailers and different sources. You can buy them in some local stores, but I'll have links down below where you can pick up some of this. On top of that, you're going to need some wire. Now you can purchase kind of pre-soldered connectors. So this is a 12 volt barrel plug, and then they have kind of this little connector on here that just clamps down around that. Otherwise, you might want to pick up some thin wire. These don't handle a lot of amperage as far as these LED lights, so you can get by with a fairly lightweight wire. In fact, being the scavenger I am sometimes, I've actually used the strands from network patch cable. I've just pulled out some of the wires from there because these are fairly low amperage and fairly low voltage. But something in maybe like probably like a 16 gauge wire, or even on to a 20 gauge wire, is going to work okay. You get much smaller than that, you risk maybe overdriving those wires. You know, too much wattage through them will cause some issues, as well as they get a little bit fragile when they're lighter. So try to find a good silicone wire. Those are braided on the inside or twisted on the inside, as well as have a nice flexible outer sheath, so that any points that might have a little bit of movement, they're not going to be causing that solid wire to become brittle. So again, I'll have a couple links down below to the wire you want. And then outside of that, we may need power supplies. So, of course, you might be able to scavenge these off of old electronics. You're wanting to find something that is a 12 volt output. The milliamps aren't going to matter a whole lot depending on your project. I try to find one that's at least 500 milliamps up to 1 amp. But again, these don't draw a whole lot in these shorter lengths. But if you were to wire up something with, 5-6 meters of them, you may want to invest in something a little bit higher. Sometimes save some of these from old electronics, especially if they're a 12-volt output. They may work well for these projects. Or if you're using the USB style, you can get the strips with them pre-soldered on, or you can get additional USB style plugins that then you would solder the ends onto the wire as well. So now for a lot of this, we are going to be doing some soldering, and I'm not going to go into an overall tutorial on soldering. It's something I picked up really in the hobbyist realm years ago with my RC hobby. It's a good skill to have when dealing with various electronics, whether it's fixing your laser, fixing small light fixtures and other things. So it's something to practice, and there are some fun kits you can get, whether it's a digital clock or whatnot, to practice that. But I will try to give a few tips and tricks here, but again, this isn't a full soldering tutorial. If you're not comfortable soldering, they do make these clip-on connectors that will basically snap onto each side of the LED lights, and that will allow you to run them. But if you want to incorporate a switch into this, there is going to need to be some soldering to get that incorporated. So hard to get away from that, but I will try to walk through the basic steps on it as we can. So of course, with that, you will need a soldering iron. You don't need anything real heavy. You definitely don't need a soldering gun. That's going to be overkill for this. That's great to have in your workshop if you're dealing with light electronics. Sometimes you need to resolder a fan wire on your laser, or you want to add LEDs to a project. It's a good skill to have and practice on. So this isn't a full soldering tutorial, but I've tried to give you some tips and tricks. So let's jump in a little bit closer, take a look at these LED lights and how we're going to work with them. Here is our roll of LED lights, and I'm not sure. I think this is this is more of a yellow color. I've been using these for a while on various RC applications, and so I'm just going to be using this up as some of our practice material. But taking a closer look at this, if you have a random roll like this that you don't know exactly what it is, we can see it here. If you look closely, it's marked as a 12 volt. And then also you want to take note of your symbols on here. So we have a positive and a negative side. So that is going to be labeled on every joint here. And as you see here, if we take a real close, you have like that scissor symbol with the line. That's where they're guiding you to where you can cut these. So some things to keep in mind with these. Generally these are going to vary, but you'll have anywhere from a 2 to 3 inch length on these sections, depending on your strip of LED lights. So it gives you some flexibility, but you want to try to factor that into your project on where you cut those. So you want to find the line closest to the length you need and then cut them off. So then also we have our barrel connector here with our leads coming in. These are what we're going to be soldering to those wires. And so we've taken this back a little bit, and we'll still need to strip off the very ends to get at the actual wire. But the color coding on these for DC voltage is red's going to be your positive, black is going to be your negative. So that is going to line up with what you have on here, is that you're going to want to be soldering your red to positive. So it would go like this: red on positive, black on negative. All right, so I'm going to take our first section here. We're just going to take about 3 section here, and I'm just using side cutters. This actually came with a 3D printer, but this will work pretty well. We're just going to go right down the middle of that, clip that in half, and so you should have those little copper contacts on both sides, and be able to work with each one. Now we've also stripped back the wire on our initial connector, so you want to have maybe about an 1/8 inch here. You don't need a lot of the wire here, just enough so that we can actually get them soldered down to these leads here. And so really a 1/16 would even do, but just don't go overboard so that they're going to short out and leave yourself enough room to work. So the first thing we need to do is prep both sides, and that's where you're going to need something called flux. This is a paste that you can apply to wire or surfaces. What it does is cleans the wire as it heats up, and then that allows the solder a nice clean surface to solder to, and it'll have a good joint. If you try to do without it, it might not attach. You might get a cold solder joint, and then it's more likely to fail. This is well used, as you'll see. I've used it quite a bit. So the other thing you might need is just a little toothpick as an applicator, because what we are going to do is we are going to just take a little bit of this flux. So I'm going to get it on the toothpick, and I'm going to come in here and just dab a little bit on each of those pads. So that'll allow that flux to clean that contact point. And then we will take our wires, and actually I just kind of dip it into the flux, making sure it gets some on the wire. You don't need too much because otherwise it'll drip off and make a little bit of a mess. This is a little bit sticky, so you might want to have a paper towel handy for cleaning this up. But at this point, we need our soldering iron warmed up, and we are going to grab some solder. Now, this is an old roll. Look at that, Radio Shack. Silver bearing solder. There's a number of different types. They'll have some rosin core and some other things. But just get some solder that's good for electronic wiring. This is a fairly narrow gauge. We don't need to be using a lot of it. And so this will work really nicely. All right, if you do a lot of soldering, it's nice to have something like a helping hands, but I'm just using a clamp here to hold this up and out of the way, and or a weighted block to hold my material down. You want to be careful of the heat, and so I actually probably won't want to do this right on to that surface without something protecting it underneath. So I'm just going to take a little piece of metal to help dissipate any heat under there and not burn our pad too much. Now, I've got my soldering iron here. I'm going to heat it up, and then usually they will have some sort of like wire or foam pad that can be wet. You want a very clean tip there. Now, after you have the clean tip, what you want to do is pre-tin your soldering iron. So we're just going to take a little bit of solder, and we just get that little dollop right on there. So now that we have put flux on our wire, we just want to touch these to let that soak in just a little bit of solder on each one. You don't want to hold it on there too long, or the heat will start melting the wire some. So just to get them so that it flows all the way through. Now, solder is going to flow towards the heat, so I will often put it on the back side, and then I will touch the solder to the opposite side. Now for the LED strip itself, we have the flux on those tabs. We just want to take the tinned tip of the soldering pencil and touch it on there until we see the pool of solder resting on there. Do both tabs, and we'll be ready to move on to the next step. All right, now to join the wires to our lead, we want to, again, we want to look at our orientation. So we've got the negative wire down here on the left and the positive on the right. So now that we have both that surface tinned and this surface tinned, we just need to make sure that our soldering tip is clean, and then add a little bit of solder to that to tin the top there. So I'm just going to add just enough, and this will allow the solder to flow. Now, it's very important that you don't let things move when you're joining them together. If they move after you remove heat, that can cause a cold solder joint. So we're going to hold it in place, just tap it to get the solder flowing, and then that one's connected. We're going to come back over here to the negative side, get that lined up, touch that to place, let the solder flow together, and now both sides are joined. So I have my 12-volt lead here, so we should be able to see if these work. I'm just going to go ahead and plug this in, and they do in fact light up. All right, so now that we have our first section and we know it works, we're going to go ahead and mock this up on a board here, because this is going to help us out. And one of the nice things about most of these LED strips is on the back, they actually have a little bit of an adhesive layer. It's not crazy strong, so you may need to go back and reinforce this on some things, especially if it's like on a non-finished material like this. If it's like a plastic or a nice smooth material, it'll probably stick better. But just gonna peel back this layer, and we're gonna go ahead and lay this down as if we were putting it on our material in our enclosure or whatever our project may be. And you see there, it is stuck in place. So next what we want to do is we want to actually bring another strip around. So I've cut another section here. As a matter of fact, I'm going to trim it down. So just show you here, I'm using, these are just side cutters from a 3D printer. And I'm going to just hit that middle point there. So what we can do is actually bring this down here. We will stick this on as well. And then we will be able to use wire to bridge the gap, because this is very rigid. You can't flex this around. You can try folding it over, but eventually that will break. So this is where we want to make our connections with wire for jumpers. So I'm just going to space it apart a little bit here. Stick that down. Doesn't need to be crazy accurate and straight, but what we're going to do is we're going to join this connection next. So I'm going to take a small section of wire, we'll make a loop, and then we'll solder it on. All right, so once again, let's test this out. If we apply power, now both strips are lighting up. So that's how you can bridge a gap using some wire. Again, you just want to watch those polarity. So now let's add in, if we were going to add the switched one. And first, we're going to talk a little bit about the switches I used. So let's talk about the switch. The switch is just a mechanical break in the circuit. And so it's going to just disconnect one of the sides of the circuit. So in this case, we're going to be using the positive side, and we're going to be interrupting that. And now I'm using limit switches because they are a nice spring-loaded switch. It's basically like a momentary switch that when you press it, it changes its condition. Now, these can be wired up in two different ways. They can be normally open or normally closed. When it is in normally open, when it is in this phase where it's not pressed down, it does not close the circuit. When it's in normally closed, it would be active until this hits, and then it would open up the circuit or disconnect it. So the way I have this set up is that when the door comes down and a little block pushes on this, that closes the circuit and it lights up that extra branch. And that's how we're going to set it up. So we're going to want to use the normally open, because when the lid opens up and it releases that block, we want it to shut off the circuit to those extra lights. So let's zoom in a little bit closer and take a better look at that. All right, so here's our limit switch, and it is very small, and it's a little hard to see, but I'll try to get the light reflecting on it just right. You will notice that we have 3 pins here. One is C, that's going to be your common, so we're going to wire up the lead coming from the light or to the light there, and then we have NC or NO and NC. So we want this to be normally open. So we're going to be soldering to this middle pin, and the one that says C, we're going to ignore the NC pin because, again, we want it to be normally open. We want the circuit cut off when it's in this mode, but when the block hits that and closes the circuit, it turns on those lights. Now in this scenario, orientation can help our wiring. I'm actually going to place, since our negative is on on the bottom here, I'm going to put the negative on the top here. That'll just help us not have crossing wires so much. So I'll spread this out just a little bit more. So we're going to stick this down here. So again, negative is on top now, whereas negative is on bottom here, and then positive. So we're going to solder in our negative wire, and then we are going to solder in the positive to one side of this, and then the positive coming out from the common. So again, using the middle pin and the second pin. All right, with that all wired up, now we get to test it. We're going to plug this in. Our top two come on, and then when we hit the switch, our bottom one turns on and off. So if the lid was closed, it would turn on. Lid was open, it would turn off. So there you see, it's fairly simple. Connection to connection there, just straight. Here, running just the positive leads through the switch to then let that hit the switch to turn them on. Lid opens, turns them off. So on the case itself, here is a closer view of the block and the switch mounted in there. So as you can see, this block will come down and hit that switch, turning them on. And if I lay this down in here, you might be able to see that. So I hope that is enough of an overview, enough tips in there for the soldering and using the right wire and switches to set up something similar. Now, this could be on my design, or it could be on any enclosure you have where you might have doors that you want to have some lights on them, but not have them glaring at you. Otherwise, just using up those wire and the power without the switch, you can use that in any number of your projects to add some LED lights and be able to do it a little less expensively than buying individual strips and requiring on the commercial added. Like I say, soldering is a good skill to have. It allows you to do basic repair on electronics, as well as add some lighting and other features to your project. So hopefully this has helped inspire you. If you've built one of my enclosures, want to add it, sorry this took so long, but hopefully that'll help you out there. Otherwise, if you have other ideas on using them, I'd love to hear about them. Leave some comments down below of how you've used LED lights or how you might use them. And if you have any questions, need some clarification on that, hit me up down there as well. So anyway, I will have links down below to a lot of things I've used in this, from the LED lights to a decent soldering gun, different tools that will hopefully help you be successful with this, along with the wire and the limit switches and such. So appreciate you using those. There will be affiliate links. They do give a slight kickback to me, which is a nice way to support this channel at no additional cost to you, and get you the things that I know have worked well for me. So thanks for watching this video. If you found it useful, appreciate hitting that like button. If you're new here, hit that subscribe button. I do all sorts of things in my workshop. A lot of it's based around lasers, some CNC, some 3D printing, some even traditional woodworking and such, but just enjoy sharing what I'm doing in my workshop and helping inspire others. So if I've earned it, hit that like button, hit that subscribe button, and leave a comment down below. Otherwise, thanks again for watching. I hope to see you again soon, but I hope most importantly you get out in your workshop and make something too. We'll catch you next time.